Hello, fourth grade, and welcome to the last lesson of topic 15. We're on 15-6. This lesson focuses on using appropriate tools. So out of all of the tools that you've learned about, picking the right one that you need to solve a problem. Let's go ahead and watch our short video lesson together, and then we're going to go over our notes and go into our guided practice.
How can you select and use appropriate tools to solve problems? Think about this question during the lesson. Trevor and Holly are drawing trapezoids to make a design. They need to find the measures of the angles formed by the sides of the trapezoid and the length of each side of the trapezoid. What tools are needed to find the measures of the angles and the lengths of the sides? Think, what do I need to do to copy the trapezoid? I need to measure the angles, then measure the sides. Think, which tool can I use to help me solve this problem? I can decide which tool is appropriate, explain why it is the best tool to use the tool correctly. What tools could you use to measure the angles in the trapezoid? You could use a protractor or pattern blocks with known angle measures. Why is a protractor the best tool to use? A protractor can be used to measure angles of any size, whereas pattern blocks can only measure angles of certain sizes. Here's my thinking. First, use a protractor to measure the angles. The angles measure 120 degrees and 60 degrees. Which is the best tool for measuring the lengths of the sides?
Select your answer.
Use a ruler to measure the length of each side. The lengths are 3/4 of an inch, 3/4 of an inch, 3/4 of an inch, and 1 1/2 inches.
Now you know how you can select and use appropriate tools to solve problems.
All right, let's go ahead and get into our notes and our guided practice. Okay, so using appropriate tools. So think about the tools that you've used in the chapter. You learned how to use the angle measures found on different pattern blocks. You've learned how to use a protractor. You also already know how to use a ruler and a lot of other tools such as fraction strips and things that we've used throughout our math book. So let's go ahead and take a look at our first example. It says 1/8 of the pie is missing from the tin. What tools can Delia use to measure the angle of the missing piece? And how can you calculate the measure? So first thing, I know that I can try to use pattern blocks or a protractor to measure the angle of a missing piece. Either one of those tools will be helpful to me. I know that a pie is shaped like a circle and that a circle is 360 degrees. So I need to find 1/8 of a circle, or 1/8 of 360 degrees. So what I'm going to do is take my 360 degrees and divide it into 8 equal parts. And that gives me 45 degrees. So the angle of the missing piece is 45 degrees. Now I can use my protractor to check my work. So remember, when you use a protractor, the hole right here, you line up with the vertex or the end point. That line that you see on the bottom of the protractor, you want to line up with with one of your rays. And then you're going to see how far it goes on there. Now, sometimes you'll come into a situation like this where it doesn't reach. So what I can do is I can take like a piece of paper or a Post-it note or something and line it up with the edge of that top ray that I'm going to use to measure. And then I can reline up my protractor and I can see exactly how far it goes now. So it's right in between the 40 and the 50. So right in between 40 and 50 is 45 degrees. Now, the reason I'm measuring from the inside is because my angle is pointing to the right. So I'm going to use my ray is pointing to the right. So I'm going to use the inside measures. If it's pointing to the left, I'm going to use my outside measures. Okay, let's take a look at another example here. It says find the measure of all of the angles below using a protractor. So I'm going to measure these different angles using a protractor and figure out what my total is. I know that the angle WVZ is 180 degrees. So I know that all of these together are going to equal 180 degrees altogether. Okay, so now that we know that angle WXZ is 180 degrees, we need to figure out the measures of the other angles, and it says to use a protractor. So I've got my protractor here. Now I'm going to line up my protractor with the vertex. So remember, that's a little line, that's a little circle at the bottom. And you can see here that there are lines on my protractor. Let me try and move this out of the light a little bit for you guys so you guys can see clearly. Okay. All right, so we see that we're going to line it up with the dot. We line up our vertex inside that circle in the protractor, and then we're going to line up the lines with our lines on the protractor. Now over here, since this angle is pointing to the right and we're going to measure YVZ, we're going to start from the 0 that's on this side, and we're going to swivel up. Scoot this down so you guys can see. You swivel up until we are able to line this up. So we see that this angle here measures 70 degrees because we're using the inside angle. We're starting from this 0. So this is going to measure 70 degrees. So I'm going to take this and I'm going to label it 70 degrees. Okay. Next, we'll measure this angle over here. So we're going to line it up again, line it up with the lines on the protractor, with the vertex right in the center. And this time, since the vertex is pointing, the ray is pointing this side to the left, we're going to start with the numbers that start with 0 on the left side. We're going to be starting from here and measuring our opening. So we're going to use the outside numbers over here. So I'm going to swivel that up, line it up, and I can see here my angle is measuring 50 degrees because I'm using the outside measurements this side. So it's, if the ray is pointing to the left, you're using the outside measurements. If your ray is pointing to the right, you use the inside measurements. So we said that's 50 degrees. So I'm going to label this 50 degrees. Now to measure this one, I know a lot of you guys will get a little bit confused looking at it, saying, well, it doesn't line up. So how do I measure it? Well, turn your paper and make it line up. Now, even if you turn your paper, the measurement stays the same. You're not changing how open this angle is, no matter how you turn this sheet. So we're going to take it and we're going to line it up with that vertex. We're going to take that line that's on our protractor and line it up with our line. And you're going to treat this as the bottom. So we've got everything lined up. And then since we're working on this side, it's pointing here. So we're going to start at the 0 on the outside measurements. We're going to use the outside measurements. So I'm going to take my protractor, I'm going to swivel it up until I get to my measurement. Here I can see my angle measures 60 degrees. So this inside angle here measures 60 degrees. So now I've used my protractor to measure all of my angles, even though I had to turn my paper at one point, even though I had to, flip sides and use the measurements on the opposite side. So the first time I used the measurements on the inside from the right going out. The second time I use my measurements on the left from the outside, from the left going towards the right. So now that we have all of our angle measurements, we're going to see if those angle measurements add up and they equal our 180 degrees. So I have to add these angle measurements to see, does the total equal 180? Because we know angle WVZ, the straight angle, is 180 degrees. So I need to add 50 and 60 and 70 to see if that works. So 0, 0, 0 is 0. 5 and 6 and 7 equals 18. So my answer does check out. It does equal 180 degrees. So I know my angle measurements here are correct. Let's go ahead and take a look at another example. This is one that you will find in your book as well. It says, what is the measure of the sides and angles of the parallelogram? So this is a three-part question. First, it asks, what tools can you use to solve the problem? Next, explain how to use the tools you choose to measure the angle, and explain how you use the tool that you chose to measure the length of the sides. So I need to stop and think, what tools do I know how to use? Well, I know that to measure length, I use a ruler. And to measure angles, I use a protractor or pattern blocks where I know the angle measures. So for this one, I think the easiest thing for me is I'm going to choose to use a ruler and a protractor. So part A, I'm going to use a ruler and a protractor. For part B, how will I use that tool to measure the angles? Well, I'm going to line up the vertex with the center of the protractor, so that center point at the bottom, right there. And then I'm going to measure the opening of the angle. So if I'm going to line this up here, I'm going to line up my vertex, that's my little corner point. Sorry guys, I know the light is kind of reflecting. I'm going to line it up like that, and then I'm going to measure. Now, since I'm using this one points to the right, I'm going to use my inside measurements. So I'm going to measure over here, and I can see that this measures right in between the 70 and the 80. So that's going to be 75 degrees to measure that angle. This one, since we're going to be, the opening is to the left, we're going to use the measurements on the outside. So I'm going to line it up just like that. I'm going to make sure the line on my protractor lines up with my line. And then I'm going to swivel this over, and I can see this falls right in between the 100 and the 110. And I know that's 105 degrees. So this is 105, this is 75. Since this is a parallelogram, the opposite angles match. So if this is 75, the one across from it is 75. If this is 105, the one across from it is 105. To measure the length of the sides, I'm going to line up my ruler from the start of one side to the end. So I'm going to line it up starting at the 0 and measure to the end. And I can see this goes out to 1 1/4. So that means this side will also be 1 1/4. I'm going to do the same thing for this side. This goes 1 3/4. So that means this side will also be 1 3/4. All right, next we're going to get into our guided practice. Now the question that we're going to focus on and help us answer the remainder said Lee bought 1 3/5 pound of apples to the picnic. Hannah bought 4/5 pounds of oranges. Lee said that they bought 2 2/5 pounds in all. So together, when you add those up, he said that they got 2 2/5 pounds. He needs to justify that 1 3/5 plus 4/5 equals 2 2/5. So number one says, what tool could you use to justify this? Well, we know we can use fraction strips. We've used those plenty of times when we were working with fractions. Number two, how can he use it? Draw pictures and explain. So 1 3/5, so here's my 1 whole and 3/5 pieces. And then I added the 4/5 pieces to fill up that line plus the extra 4/5 pieces underneath. So here I can see I have 1 7/5, right? So 1 7/5 is the same thing as saying 1 5/5 and 2 more fifths. We know the 5/5 is 1 whole, so 1 whole plus another whole, that's 2, plus 2/5 equals 2 2/5. All right, that takes us to the end of our guided practice. If you have any questions, let me know. Otherwise, have a wonderful day. Take care. Bye-bye.